Next we have a cube root. So slow down a little bit on this one. To have a cube root means we are looking for 3 identical factors now instead of just 2. So we're going to also notice that under the radical we have a positive number. So I'm going to start with 125. Using my factor ladder, I can divide by 5. 5 goes into 12 2 times with 2 left over. 5 goes into 25 5 times. Dividing 25 by a prime, I would have 5. 25 divided by 5 leaves me 5. And 5 divided by 5 leaves 1. Notice that we have 3 identical factors. So I could write that as 5 cubed under a cube root. I have a perfect cube under a cube root, so that tells me that the base of 5 clears the radical and no other factors remain under the radical. So my final answer is 5. In our next example, again, we have an index of 3, so we're looking for cube root. We're looking for 3 identical factors. So this time I have a numerical base and I have variable bases. So I'm starting with 54, and I'm going to divide 54 by prime numbers. It's even, so I'll start with 2. 2 goes into 5 2 times with 1 left over. 2 goes into 14 7 times. 27 is divisible by 3, leaving 9. 9 is also divisible by 3, leaving 3. And of course 3 is divisible by 3, leaving 1. Remember, this is a cube root problem, so I'm looking for 3 identical factors. I could think of this as 3 cubed under a cube root. And my other factor under the cube root is 2. 3 is written as a perfect cube, so that will clear the cube root as 3. So I know that 54 is now going to be rewritten as 3 multiplied by the cube root of 2. I also notice there's 4 written outside of this radical already. So I have 4 already clearing, multiplied by 3 that will also clear, and it is multiplied by cube root of 2. Next, we're going to work with these variable terms. In order to work with these easily, I'm going to look for any exponent that is at least 3 or larger. Since x squared doesn't have an exponent of 3 or larger, all of the x squared will remain under the cube root. However, 7 is a number that's 3 or larger. So to figure out how much of this base of y clears the radical and how much remains under the radical, I can simply take my exponent of 7 divided by the index of 3 to get 2 remainder 1. This number 2 tells me that the base of y clears the radical with an exponent of 2. However, this remainder is the exponent that belongs with the base of y that must remain under the radical. So I have 1 base of y remaining under that cube root. So all I have to do now is start with writing the terms that have cleared the radical. 4 times 3 is the same as 12. So I'm going to have 12 clearing the radical. So I've accounted for that. Y squared has also cleared the radical. And those are the only terms that have cleared the cube root. So remaining under the cube root, I have 2. I have x squared. And we have y. So make sure your radical sign is covering every term that's remaining under the root. So the final answer is 12y squared times the cube root of 2x squared y. In our next problem, I can see I have a cube root problem again, and it's being multiplied by a -3. So make sure you know the difference between when a radical is being multiplied by some term and what number is indicating the index for the radical. So I've got 1080 and I have some variable bases. So I'm going to start with 1080 and set up my factor ladder. Since it ends with 0, I'm going to start by dividing with 5. 5 goes into 10 2 times. 5 goes into 8 1 time with 2 left over, with 3 left over. And 5 goes into 36 times. I have an even number this time, so I'm going to divide by 2. 2 goes into 2 once. 2 will go into 1 0 times. 2 goes into 16 8 times. I have an even number again. I'll use 2. 2 goes into 10 5 times. 2 goes into 8 4 times. Still an even number. I'll use 2 again. 2 goes into 5 twice with 1 left over. 2 goes into 14 7 times. I don't have an even number this time, but I know 27 is divisible by 3, leaving 9. 9 is divisible by 3, leaving 3. Finally, 3 is divided by itself, leaving 1. So notice how I have a set of 3 identical factors, and here's another set of 3 identical factors. So under the cube root, I'm going to have 2 cubed. Under the cube root, I'm going to have 3 cubed. And then under the cube root, I'm going to have 5, which I know I can't break down anymore. So I have -3 that already cleared the radical. The cube root of 2 cubed, remember, will clear the radical as 2. The cube root of 3 cubed clears the radical as 3. And then I have cube root of 5. And then I still have to work with x to the 9th, y to the 14th. All right, so working with these terms. 9 is divided by the index. So let's do that right here. 9 divided by 3 is equal to 3. So that tells me that x cubed will completely clear the radical. None of base x remains. With 14 divided by 3, 14 divided by 3 will give me, what, 4, remainder 2. So 4 will clear the radical. That would give me y to the 4th. However, 2 bases of y would remain under the cube root. So that would look like this, cube root of y squared. So let's put it all together. I have -3 times 2, which is -6 times 3 is -18. Then our variables that have cleared the radical would include x cubed. And then remember over here we had y to the 4th. And now we want to see how much is left under the cube root. We've got our coefficient of 5. Then alphabetically, let's see, we did not have any x remaining. But over here we can see that we have cube root of y squared. So I do have a y squared under that cube root. Here's our final answer. -18 x cubed y to the 4th multiplied by the cube root of 5y squared.